Hello and welcome to the IET 150 show, episode 3. And what an important show we have for you today. I'm Bobby Seagull, maths teacher, TV presenter and lover of all things engineering and technology. And with me for this epic week-long festa of all things engineering and technology is the IET's very own TV star, engineer and current president of the IET, Danielle George.
Hi Bobby, thank you once again for the fantastic intro. I'm still not sure about the TV star bit, but it's great to be sat next to a pro, obviously. For those that don't know me, I am currently the Associate Vice President for Blended and Flexible Learning and a Professor of Radio Frequency Engineering at the University of Manchester. And I was honoured to be made President of the IET in its 150th year.
Wow, 150th year.
Yeah.
So all week long, we've been broadcasting from the IET's home here in Savoy Place, London, with the aim of bringing you 5 episodes in 5 days, simple bit of maths, of the very best of engineering and technology stories, taking an in-depth look at what's happening and bringing you the latest news and views from around the world.
And today, Bobby, it is all about engineering is for everyone, inclusive engineering. And we have a superb lineup of guests, all helping us to explore how we can really inspire the next generation of difference makers. We want to get the message out there to everyone, whatever their background, that engineering and technology is the ultimate career choice, and that the world of engineering and technology is right there at the forefront of making equality, diversity and inclusivity central to our ethos. It's going to be a packed show for sure, Bobby.
Absolutely. And getting the message out there that the world of engineering and technology really is open to all is such a hot topic. We have a great guest list showing just some of the awesome things that are happening to change this. So today's programme is going to be brilliant. We'll be joined by Metcalfe MP, who will discuss the engineering and technology industry's image and what the government is doing to widen the net of those who want to work in it. We'll also be looking back over the 150 years of the IET at some of the difference makers of yesteryear.
Then later in the show, we'll be meeting someone who's overcome a huge change in their life and has really benefited from technology. It's going to be a truly inspirational story.
And on top of all of that, Andrew is in the kitchen with his brand of Bakeneering. And don't forget, all week we're joined by IET Youngstown Personality of the Year, Callum Daniel, who is here to help inspire the budding engineer in all of us with experiments that you can do from the safety of your own home.
And from one young global personality to, well, let's head over to Mark, who's going to bring us some engineering news from around the world. Mark, where are you taking us today?
I don't know, but my intros seem to be getting worse every day. Well, today, Dan, we'll be in the USA, China, Europe and the UK for another weather map of news, so stay tuned.
Well, as we've previously mentioned, the whole reason for the 150 show is to celebrate the IET reaching its 150th birthday. And this anniversary gives us a fantastic opportunity to celebrate its rich history. Earlier this week, we spoke with the IET's Chief Executive, Nigel Fine, to find out what this milestone really means.
Dan, we do a huge amount, but we try to encapsulate it in delivering against our vision, which is very simply working to engineer a better world. And we deliver it through inspiring the next generation of engineers and technicians, informing the engineering community about the developments in engineering, and influencing people who have to know about what engineers do and appreciate the work of engineering. The IET today is not the same as the IET 150 years ago. Yeah. We keep reinventing ourselves, and we need to reinvent ourselves as the world around us changes so that we are appealing to newer audiences all the time.
Great to have Nigel join us, wasn't it, in the studio? And I know how much the IET means to so many people around the world. And I've heard so many amazing stories from our members, volunteers and communities around the world who are doing so much to assist where they can with this terrible pandemic.
Well, it's time now for our first guest on today's show. And I know how excited you are to have her on the show, being a fellow Geordie.
Oh, yes,
Is that
yes.
the right accent, Geordie?
Geordie, pretty good actually, Bobby. Well done, well done.
Aye.
We're kicking off our discussions today with an engineering and, more importantly, a diversity big hitter. Onwurah is a British Labour Party politician who has served as the Member of Parliament for Newcastle upon Tyne Central since 2010. Newcastle's industrial past was, like mine, Chi's inspiration to become an engineer, and she's enjoyed a fulfilling career in engineering in a number of different countries. Chi studied for an MBA at Manchester Business School and gained chartered engineering status, and she's also a fellow of the IET. Welcome, Chi. It's great to have you. And we went to the same school as well. That's so brilliant. I love that.
Kenton School,
Kenton School. Chi, why do you think there is a shortage of women engineers in the UK? And do you think it's something that puts women off from pursuing a career in engineering?
Well, the first thing I want to say is, engineering is a fantastic career for anyone. It's the best career, apart from being the MP for Newcastle. And it is, as an engineer, I worked all over the world, and every day was something different and exciting. And it's also a way in which you can make such a difference, a caring difference to the world. So rather than thinking about what was putting women off, it's what engineering can do more of to attract women to these fantastic opportunities. If organisations, and that doesn't matter whether it's a university department or a company of businesses, I've worked in lots of businesses, if you are not positively inclusive, if you are not diverse by design and making that part of your culture and shouting about that, then you will be sort of exclusive by default. And it's also just about celebrating what a fantastic career engineering is for everyone.
Absolutely.
Yeah, I feel like retraining us from a maths teacher to being an engineer now.
Yay, we've got another one.
So Chi said, why is equality, diversity and inclusion in engineering so important?
Yeah, it's absolutely fundamental on so many levels. So I'm a shadow business minister, and when I think about business in this country and our future economy, it is going to be built on technology. But if that technology, if it's not designed by people representing humanity, it cannot be humane. And if technology is not humane, then our future, we're in trouble in lots of ways. And then there's also just the exclusion of talent. Sometimes I imagine what we could have, the technology we could have, the progress we could have made. Imagine if everyone had been part of that, if everyone's shoulder had been to the innovation wheel, what world would we be living in now? It would be, it would be great. So it's essential on an economic point of view. It's essential from a social justice point of view, but on a sort of practical level, it's just so important to make our world representative of the people who live in it, and therefore better for the people who live in it.
Yeah, it just seems so obvious, though, doesn't it? But we haven't cracked it yet, have we? And why do you think that is? What needs to change in STEM for it to become more diverse and inclusive?
Yeah, so when I went to Imperial in 1984, there was like 12% of the people on the course were women. Now I think that percentage is 13-14%. 30 years, 2 percentage points. And I think we have a responsibility, all of us, because I see there's two futures ahead of us. There's a future where technology is something that's imposed on people, that people resent, that people think is made somewhere over there by people they don't know about. And then there's a future where technology works for everyone, where everyone's part of it, where people celebrate it. That is the future that I want. And for that future, we need to ensure that everybody feels part of it. We need to be like an innovation nation. Yeah.
Yeah,
like that.
nice.
I like the rhyming.
Innovation nation. Like it.
So what would you say to younger people, students at school, for example, my ones, if they weren't sure that STEM is for them, they're looking at other things, they go, but why STEM?
Well, I would say that whatever else you're looking at, STEM can be part of that. I mean, look, I'm a politician. I am using my engineering training every day. And then there's, I think STEM uniquely, and obviously I'm somewhat biased, it combines that kind of all different possibilities that you can do, but with creativity, but with also making a contribution to, to the betterment of humankind. So you get that huge sense of personal satisfaction. You get pretty well paid. Tech jobs are amongst them the best paid. As an engineer, I never really worried about not being able to get a job. Much more job security than politics. Let me say that. And so, it's just like, and on so many levels, STEM and engineering open doors. Not closing doors.
Absolutely. And as we celebrate the 150th anniversary. That's 150 years of innovation, and you were just saying before about the future and how we'll be an innovation nation. That's what you want for the next 150 years, sort of thing. Do you think in that 150 years in the future we will have solved that skills shortage and will have solved that inclusive engineering?
Putting on my crystal gaze.
Yes.
Yeah, and one of the reasons why I went into politics, if you like, is because I believe, that we build our future. In fact, that's the only reason I went into engineering and politics. And so you ask me, what will it look like in 150 years? That is something we are deciding right now. Actually, to quote a very important person, source, we need to be the change we want to see.
Yeah.
But we need to start being that now.
Yeah, absolutely. Oof, wise words. Very wise word. Thank you so much for joining us, Chi.
It's been a pleasure.
Absolute pleasure to talk to you. Thank you, and a fellow Kentonian. I love it.
All Kentonians.
It's really good to know that our MPs are starting to understand and get behind the importance of diversity and inclusivity in the engineering and technology arena.
We've just got to keep the momentum going. And right on cue, if the guys are ready, we have a fantastic video showing the difficulty we will be in if the skills shortage isn't met.
Currently, the UK has a huge skills shortage. It is estimated that the engineering industry will require 200,000 skilled engineers between now and 2024 to meet demand. Considering the scale of this demand, combined with a shortfall of approximately 56,000 engineers, as a long-term solution, we need to do more to gain enough prospective candidates from diverse backgrounds to enter the profession. There are currently just 12% of women working in the UK engineering industry. So we need to engage with those women to celebrate their success, alter perceptions, and inspire the next generation. Engineering is in absolutely everything that we do. It's a fantastic profession which can be life or even world-changing. By engaging with underrepresented groups, not only do we provide an opportunity for those individuals to embark on an incredible career, but by having diverse representation in engineering, we can harness diversity of thought, which leads to innovation.
That's a great video. It's imperative, isn't it, Dan, that we really focus on the skill shortage and what a time it is to come into engineering and technology.
Exactly, Bobby. That is the message we need to get out there, that the jobs are there. And so if you're studying STEM at school and want a truly rewarding career where you can travel, the skills are transferable, then engineering and technology is the place for you. And as we are here celebrating 150 years, it shows that institutions like ours will still be here to help you throughout your career and beyond.
Joining us now is Stephen Metcalfe, Conservative MP, first elected as the Member of Parliament for South Basildon and East Thurrock in 2010. In the last Parliament, Stephen was chair of Parliament's Cross-Party Science and Technology Committee, where he continues to serve as a member and now co-chairs the All-Party Parliamentary Group on Artificial Intelligence.
Stephen is passionate about promoting science, technology and engineering in South Basildon and East Thurrock and across Britain as the government's envoy for the Year of Engineering. He has campaigned for many years to protect our green spaces from overdevelopment and has worked with communities to find ways of engaging with young people. And I'm very pleased to see he is here with us on the sofa. Welcome, Stephen.
Thank you very much indeed. It's an absolute pleasure to be here to help you celebrate 150 years of fantastic activity.
Yeah, thank you so much. So we've heard, Stephen, some great statistics already in the show. Why do you think engineering still has this sort of image problem?
It's a great question. I think a lot has improved in the way people perceive engineers, and that was what was the motivator for the Year of Engineering, was to try and show everyone that there was a place for them within engineering, regardless of background or ethnicity or gender. And so we've made some great steps forward, but there is always more to do. And I think we all have to continue to focus on demonstrating that engineering is creative, it's rewarding, and it's open to everyone.
Yes, it's such a good message, isn't it? But we know that there is still a skills shortage and you know, the government has a central role to play, doesn't it, in solving that skills shortage. From a government perspective, what do you think could be done more to attract more diversity into engineering?
So I think the things that we need to do is it's not just down to government. I mean, I think we've made great progress in the way we teach STEM, science, technology, engineering and maths in schools. I think there's a role for government in that, but I think there's also a role for organisations such as the IET, but also for businesses. And I think that what we actually need to do is use parliamentarians as their local champions in their constituencies to work with engineering businesses and your members and other members of other learned societies to go out and engage with schools, to create a kind of excitement around what engineering is and what it can do to solve some of the great challenges we face here at home following COVID, but more widely across the world. As we have a growing population, we've got to feed that growing population, we've got to provide sanitation, clean water, deal with climate change. These are exciting, big challenges. And if we can get that excitement across to people, I think we can improve that diversity.
Absolutely.
Actually, picking up on that further, so obviously talking about governments, organisations, business, but I'd like to sort of delve into further what parliamentarians like yourself can actually play individually a role in solving the skills shortage.
So I think we are, as parliamentarians, inherently inquisitive. That's why we go into politics. We want to help people, obviously, but we're also interested in our local communities. And acting as a bridge between our local community and the wider engineering sector, I think, is one of the key roles we can do. And that's why if you keep it local, if you get your members, your membership organisations to engage with their local members of parliament, you can use them as a resource to go out and spread that message at a local level. For example, I'm very fortunate in South Basildon and East Thurrock that I have Leonardo, who are obviously involved in satellite and tracking radar systems. I've got Case New Holland, who build 1 in 10 of the world's biggest tractors. It's an extraordinary site. 1 every 4 minutes rolls off the production line. You wouldn't think that, but it's engaging with young people and showing them that behind these, sometimes grey buildings on grey industrial estates are some of the most exciting things you can imagine being achieved by engineers and scientists and mathematicians. So that, I think, is how we can play a key role. And I would be happy to work with the IET to sort of expand on that and engage with parliamentarians.
Brilliant. So, we've got institutions like ours, the IET, we've got government, like you say, we've got the sort of education pipeline as well, we've got society as a whole. How do we all get together and help people understand the huge role engineering and technology plays in our everyday lives?
That is the big question. So the Year of Engineering was a good start, and one of the things I was most warmed by during the year was the way that all the engineering organisations came together for one simple purpose, which was to improve the perception of what engineering is. And I hope that work is still continuing. I was then the government's envoy for engineering for a while until last summer. I know that the sector as a whole is continuing to work together. There is now an engineering code of conduct, which I think is a useful tool to bring that sector together and continue the good work that's been going on. I think it's just perseverance. It's just carrying on with the message that engineering is open to everyone and will help us solve some of the big challenges.
Yeah. Great message, and we'd love to work more with you for sure. Stephen, thank you so much for joining us. It's been a pleasure to talk to you. Thank you so much.
Well, thank you for inviting me, and congratulations again on 150 years.
Thank you very much.
Well, some great views there from Stephen. Moving now to our next guest, it's Carol Vorderman, MBE, a household name here in the UK, best known for co-hosting the game show Countdown. She's a newspaper columnist and author of educational and diet books. Bringing maths to the masses, Carol has been an idol of mine for a long time.
Oh, I love a bit of Countdown, don't you? Ooh, I'm glad that was your bit.
So was I.
Carol is a passionate communicator on all things STEM. She read engineering at Sydney Sussex College, Cambridge, and went there as one of the youngest women ever admitted at the time. It really is the one and only Carol Vorderman. I'm really excited for talking to you. You are such a well-known ambassador, not only for maths, but I think for STEM generally, certainly in the UK, but in other countries as well. Do you see yourself as a difference maker?
I think now, now I'm older. When I started on television nearly 40 years ago, when I was 21, I'm 60 now. And I didn't see that. I mean, I was just, 21-year-old getting a job, really. And then things kind of went from there. So I suppose anybody who's been around for that length of time, it goes like the wind, let me tell you, like the clouds. I think I believe that you have a duty to give back.
Your story, free school meals, comprehensive, getting to Cambridge, that must inspire a lot of young people, particularly young girls, to go, do you know what? If she can do it, I can do it too.
There's a lot of doing down of women generally, which is very sexist stuff. So it's very difficult for me to get my story into the newspapers. If I wear a bikini, your front page, right? It's standard. And, if you do anything like that, what does somebody wear? What does somebody look like? Is how women are still portrayed. I've been ambassador for the Air Cadets for years. I've done, I've got to go on a Zoom conference with some astronauts at NASA in a moment because I'm on the board of directors of the Challenger Centres and so on. And that's actually the reality of my life. Try and get that into the media. And therefore this whole role of women who are engineers or into STEM, I still find it very frustrating, really, really, really frustrating.
Yeah, I do as well. Would you still encourage young girls to go into STEM though?
That I think if engineering at school was pushed more, but I think you'd get many, 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 many more children, male and female, wanting to do engineering if it were available at a younger age. Much as you would love a student to do a degree in engineering and then become an engineer, I think it should be sold as this really is the golden key. And people now with a good physical natural sciences degree or an engineering degree, they can just kind of write their own check, can't they?
I've got a question for you. As a maths teacher, kids ask me great questions all the time. What's the best question you've been asked?
Well, I mean, I teach 500,000 children their maths at the moment on the Maths Factor, which is my online maths school. And they ask all sorts of questions, but they're quite innocent ones. So they would say, what's your favourite number and why? Which is a very difficult question, actually.
That is. What is your favourite number?
Well, I'm never quite sure. I answer differently every time on my mood. If I'm feeling a bit lazy, I say number 9 because it's a magical number and there are lots of tricks you can do with it. And then I can show them all of those tricks. So I would say 9. I suppose I'm always looking for patterns, really. And I would say 9 because there are so many easy patterns to spot.
Oh, well, Carol, it's been so lovely to talk to you. Thank you so much for your time and all of your amazing input. Thank you.
Thank you. All the best.
I love numbers. Carol's been a really huge inspiration to me and millions of people all over the UK. What an absolute legend.
She really is, isn't she?
Have you got a favourite number?
Well, I have. Mine is 0 because lots of people, there's a big debate, is 0 a number or not?
Oh God, we could have a whole IET lecture series about this.
Yeah, let's do it.
Have I told you my favourite number?
No, you haven't. Tell me.
It's actually 2. So it's prime numbers. 73, which is the 21st prime number, and you flip 73 to make 37, and that is actually the reverse of 21. That's the 12th prime number.
Really?
But I'm a bit annoyed. Sheldon from Big Bang Theory, he's stolen it as his favourite number. So people think I nicked it from Sheldon, but I had it always as my favourite numbers.
You were there first.
Yeah.
You can see we were honestly thrilled Carol could make it, but by no means any less inspirational. Next up, we have Henrietta Heald. Henrietta is an acclaimed prize-winning author with interests in British history, architecture, feminism, and the countryside. Titles include Magician of the North, a biography of William Armstrong, the great Victorian inventor, industrialist, and visionary. She's currently writing The Extraordinary Life of Rachel Parsons, an inspirational feminist pioneer who was violently killed in 1956 at her Newmarket racing stable. But let's start with her amazing book called The Magnificent Women and Their Revolutionary Machines.
Well, welcome. So your book, Henrietta, looks at the formation of the Women in Engineering Society in 1919. What was the inspiration for writing the book?
Well, I think it was the women themselves. I mean, they are just such an amazing load of characters. I mean, every single one of them. And they come from all walks of society, really. That was what was so nice, because they came together during the First World War. A lot of them worked in the munitions factories. And then after the war, of course, they were told they weren't needed anymore. And quite a lot of them were annoyed by that, because you know, they'd learnt so much. They were skilled. They'd actually had independent living for the first time in their lives, and then just suddenly be told they weren't needed. And so that's what's given the impetus to form the society.
Yeah, and I think that's why they're so popular and so successful as well. I'm loving it. I'm reading it at the moment. You worked with the IET Archives team, didn't you, for information for this book?
Yes.
What was the research phase like? Did you get to see some of our archives? Because I know they're brilliant.
Yes.
And did you find out anything that surprised you when you were doing your research?
So the archives didn't just cover the founding of the society, but as it went on, all the other characters who became involved. For example, somebody like Amy Johnson, who people don't realise was the president of the Women's Engineering Society. She was actually herself a trained engineer. I mean, she's known as this daredevil character.
Of course,
But she was the first woman to have a ground engineer's licence. And so, you know, she could repair her plane when it crashed, which it did. And, you know.
Useful.
Yeah, very useful.
I think your book is a really good starting point for people, you know, who want to understand even what the issues are today. Was that something that you had in mind when you were writing it?
I actually hope to inspire. To me, it's all about telling good stories. And I think these women have such extraordinary stories to tell.
People love stories.
They do, don't they? Yeah.
Exactly.
Yeah. Oh, Henrietta, I could talk to you for hours, literally. Oh, thank you so much for joining us. I'm very
delighted.
good. Best of luck with your book.
Thank you,
Thank
Danielle.
you.
Thank you.
Thank you. So if you want to find out more about Henrietta's great books and future books, they're available at all good bookshops.
Our next guest really does showcase the amazing work of women in engineering and technology happening today. Ella Podmore is the IET's Young Woman Engineer of the Year.
There's so much more to engineering than solving problems and fixing things. So what makes an engineer tick? Growing up, I love science, experiencing firsthand the impact it had on the world and people around me. I knew early on that I wanted to get involved. There was always this great urge inside of me that strived for performance. But why did I become an engineer? To make something better than anything else, to break records, to go faster. I always pushed myself and my work to the absolute limit. Sport had always been a channel for this competitive edge. My desire to evolve my process and my practice, being part of a sports team really taught me that some of the smallest changes are often the most important. How pushing yourself can excel an entire team to success. That feeling of wanting to be a part of a dynamic team environment, that's what drew me to McLaren. And being the company's first materials engineer, I'm so fortunate that I get to work on some of the world's most advanced materials. The changes that I make are really small, they're microscopic, but it is at this microscopic level where we make the difference. And it is here where we're able to make a lightweight car even lighter, and here where we're able to fine-tune that product for performance. Working on some of the world's fastest cars makes me feel like part of a materials technology movement. And I want to use this platform to broadcast all the work that those materials engineers are doing on a microscopic level to better industry. For the young girls and boys who are looking to engineering for a career, wondering if it's quite right for them. But for me, more importantly, I want to use this platform to broadcast the work that engineers out there who are doing more than just safety and function. Why not take it to the edge? I have found engineering to be groundbreaking, beautiful, and I cannot wait to see where this winding road takes me next.
And we're really lucky Ellen has taken some time out from McLaren to join us here. Welcome, Ella. Great to see you.
Thank you for having me. This is amazing. I feel really lucky.
Yeah, so you're our current Young Woman Engineer of the Year. Huge congratulations.
Thank you.
Ella, what do you hope to do with this platform?
Oh, well, and what a platform it is. I'm honestly, firstly, so honoured. I know all the finalists that I was up against are doing some phenomenal things. And I would like to use this platform as a sort of, to showcase all the amazing women in the automotive industry. So we know that there is gender disparity in STEM roles for female representation anyway. But I believe the automotive industry is significantly further behind the rest, like aerospace, materials, whatever it may be. So I'm really excited to show what automotive ladies do and what amazing careers there are to work on cars.
Oh, brilliant. And talking of amazing careers, tell us about your role at McLaren and what is it like to work in a male-dominated industry?
Yeah, so I absolutely love my role at McLaren. I am a materials engineer, as you quite rightly did in my lovely intro. And I am responsible for all material-related investigations on the car. So being a supercar, we pride ourselves in lightweight technology, super fast lap times, anything that's going to make our car a greater performance model, basically. And as a materials engineer, it means that I'll design weight out of the car by speccing the correct materials or looking at carbon fibre layups, for example, how we are going to make our car more efficient. And of course, the luxurious element of it too. So whether we have some gold, some diamonds on there, that often gets headed my way into the lab.
Nice.
And yeah, a good perk of the job. And yes, it's no secret that the automotive industry is male dominated. I think there is a stigma still associated with cars, with supercars, that it's quite a masculine energy. So when I first joined the industry, probably around 4 years ago now, I definitely noticed that I'm the only woman in the room. And this has improved significantly over those 4 years. And I'm pleased to say that there are many more women in product development roles, engineering roles, and it's really good to see. But we still need to showcase these professions and show young people that you can do this type of job in this industry, and you can be yourself, you can do this without changing on acting like a tough masculine persona of yourself. So that's what I aim to do.
Thank you. It's excellent to see that progress, and thank you for being that role model. So McLaren is a truly advanced engineering and technology company. What's the best part of your job?
That's a hard one.
That is a hard one. I know what you're going to ask me. Yes, I do get to drive the cars.
Brilliant.
And honestly, that's a wonderful perk. And I think it's unique to the company. We are a relatively small company if you compare us to the rest of the larger manufacturers in the world. And a perk is that I get to see how these cars perform, and that's really special. It's great as an engineer to get close to the product and experience what you're working on. I think it boosts morale, and that's something that McLaren family have. It's very unique to us. But like I mentioned, I have some really jazzy options that come on these cars, and whether it be in the form of 24-karat gold, whether it be in luxurious leathers and stuff like that, it's my job to ensure that no matter what colour we spec, no matter what elaborate decision or option we have on this car, that withstands the temperatures that our exhaust systems get up to. It withstands all the different regions that we ship our cars to, whether it be high UV, cold temperatures, for example. This is the kind of thing that I'm running experiments with in the lab. So I get some lovely perks, and as you can tell, I enjoy it.
Yeah, brilliant. And so you should as well. There must be struggles as well, though, from a sort of a technical point of view, as well as sort of you personally in your career as well. Tell us a couple of your struggles in your career so far.
Yes, and I think it's important to discuss that as well, because not everything is, you know, plain sailing, and you quite rightly picked up on it. I was the first materials engineer in McLaren Automotive, and I think that's two major challenges that I had to face coming into the business. One being a female engineer, which I wasn't heavily represented in the company already, and being the only materials engineer, fresh graduate from university. That was pretty tough to try and make people understand what I'm talking about, why they've got to make smart material choices. So only female in the room, only one of my technical profession in the company. That was really tough, trying to make people understand why we've got to switch to a different material, why we've got to spend more money on coating specifications. So I learned quite quickly that you had to be yourself in an industry like that. I was very bravado and going in thinking I had to change myself to make people listen, and it was a sort of a learning pathway for me to understand that actually be true to yourself, and people will understand, and back it up by science. We're in a lovely profession where, you know, it isn't all about opinions. If you don't believe me, I'll just go and prove it in the lab and write a report. So
Brilliant. I love that advice. That is great. Thank you so much, Ella. What a fabulous guest. Love having you here. Thank you so much.
There are just so many great careers in engineering and technology.
That's right, Bobby. Just about everything we touch nowadays has been engineered. And I nearly forgot, YWE nominations for this year's awards are open until July 5th, with the winner being announced in December. Go to youngwomanengineer.theiet.org to find out more. So, what's coming up, Bobby?
Well, Dan, it's been a packed show already, but still to come. We'll be joined by James Young, an avid gamer who tragically lost his arm and leg in an accident on the London DLR. He's here to tell us how a bionic arm from a gaming company helped improve the quality of his life through the use of technology. And our resident 150 show chef, Andrew Smyth, will be demonstrating why spaceships don't burn up on re-entry, so stick around. But first, throughout this fantastic 150th IET birthday week, we've been sharing stories from our Difference Makers series, a series of mini documentaries showcasing amazing engineers and technologists throughout our 150-year history to help raise awareness of some of the incredible work the engineering community has done and has laid the foundations for what we know today.
The all-electric house was commissioned by the Bristol branch of the Electrical Association for Women and built in 1935. The Electrical Association for Women was an international organisation which had formed in 1924 as a sister organisation to the Women's Engineering Society, and its mission was to popularise the domestic use of electricity.
The Electrical Association for Women was formed in 1924, adopting the slogan "Emancipation from Drudgery," with the aim of encouraging women to be consumers of electricity and to educate them to be more knowledgeable about electrical apparatus. They are also a mouthpiece to express a woman's point of view when it came to electricity in the domestic setting. The records held in the EAW archive are evidence of the volume of work involved in this endeavour that spanned continents with branches as far away as New Zealand and the Caribbean. The EAW finally closed in 1986 after over 60 years of operation. A publication written in approximately 1936 embodies everything that the EAW stood for, equipping a home with modern electrical conveniences, whilst educating both the consumer and the manufacturer on what was required to run a functioning home. The all-electric house was proposed by the EAW to provide a comfortable and pleasing dwelling for those on a modest income, which was an important feature in the EAW's work. The cost of the house was fixed at £1,000 and was to include construction, main appliances and furnishings. The challenge was to find out whether manufacturers could supply equipment that was requested by women at a reasonable price, and to incorporate these into the design of their home. It was also to encourage women to take more interest in the design and usability of the home. The site chosen was in Bristol. Emphasis was placed on the benefits of using electricity over traditional methods to heat and light the home. The benefits included financial rewards, as well as efficiency, cleanliness, quietness and safety. These were as important to the consumer then as they are now. A simple comparison with the all-electric house and new builds today shows that innovative materials and building methods are key in providing affordable homes that are sustainable and do not have a negative impact on the environment. The modern design included electric lighting in cupboards and wardrobes, lighting in recesses and concealed lights, a refrigerator and hide appliances that included a water heater, wash boiler and electric cooker. Prominence was placed on the construction of the home to provide optimum insulation, making it as efficient as possible. New, innovative materials such as vitrolite was used in the bathroom, which was both aesthetically pleasing but also sanitary. Today we talk of smart designs to maximise space efficiently, but this was also of prime concern in the all-electric house. Cupboards were integrated, a dresser in the kitchen incorporated an ironing board, the front of the kitchen cabinets would fold down to form a table, and folding seats were attached to the walls. Room dividers helped create separate spaces, whilst the bedroom fires were controlled from the bed, allowing for that little extra luxury in the cooler months. As the method of heating was by electricity, there was no need for fireplaces or chimney breasts, which created extra space in the all-electric house. Appliances were also placed on display to show the prospective consumer what could be achieved with the modern technology available. The EAW all-electric house achieved all of this and more by showing that a home could be designed and built at a reasonable cost that incorporated the equipment required for running a modern household.
It's amazing seeing that, to think that even in my lifetime, how far the growth of technology we have in our houses has moved on.
Yeah, absolutely, I know. Fridges connected to the internet, making orders online, solar panels on roofs, LED lights that can be dimmed from your phone and turned off and on wherever. It's truly remarkable.
Oh, totally. Technology is really making a difference to millions of people every day. But our next guest has utilised advances in engineering and technology to improve his day-to-day life out of an absolute necessity.
Yeah. James tragically lost his arm and his leg when he was dragged onto the tracks between two carriages of the London DLR as it was pulling in. Despite his loss, James refuses to let it interrupt his life, his love of travel and his passion for video games. James was given the opportunity to design his own bionic arm funded by the video game company Konami to coincide with the launch of their new game, Metal Gear Solid 5.
The gaming and technology media gave the Phantom Limb project a lot of attention. It's an incredible design and alternative functions challenge what the human body can consist of, with extras like Wi-Fi capability, a small screen for receiving social media notifications, very important, an email, and a USB port for charging a smartphone.
One of the reasons James was chosen to be the recipient of the bionic arm is that he is an avid gamer. After his accident, he taught himself to use the controller for his PlayStation, using his chin, lips, tongue, and teeth as replacements for the missing hand. The arm is an example of how James is challenging society's idea of the future of the human body. And we are delighted that James is in the studio with us. Thank you so much for joining us, James.
No worries, good to be here.
Yeah, James, you have such a positive outlook on life. How did you adjust to life after your accident?
I guess at first I was quite surprised because I don't have any recollection of really what happened to me. So I woke up in hospital, was a bit clueless. And it sounds a bit trite, I guess, but the first thing that I really thought about when I found out that I didn't have an arm was how will I use a controller?
Oh, okay.
That is an avid gamer.
Because I felt like all these other challenges, I had the idea probably from media and movies that I'd be equipped with replacement limbs and technology to just rebuild me. So it wasn't quite like that in the end.
In the sort of rehabilitation, what were some of the biggest challenges you faced?
I think probably just facing that idea of, oh, the things that are available aren't necessarily that amazing.
Right.
And there's a lot of cost implications of trying to equip yourself with the latest stuff.
Okay.
So it is quite challenging, but there's been lots of improvements in that area since that time, so it's been quite good.
So tell us about how Konami heard about you and how they got in touch with you. It must have been surreal.
Yeah, I mean, I was just attending my normal clinic, basically, and they had a poster on the wall with, I think it was a leg with speakers in it, on a little pamphlet. And I was thinking that that's really cool, and that sort of challenged my idea of what could a human body consist of. And there was a little form to fill out just saying, would you like an arm? Would you like to design your own arm? What would that be?
Right, so tell us some functionality. What have you got on this?
This one is purely functional, so it just is controlled by EMG electrodes in the socket. So
Right.
the signal data from my muscles is translated to the hand, and the hand will operate according to the signals I output.
I mean, you must be quite an inspiration to other people as well who have lost limbs. Do you know, have people been in touch with you and said, you know, that's amazing, you know, I want to do what you've done?
Yeah, I didn't super expect it, because when I signed up for the project, I was just thinking, oh, I'll get an arm. And maybe I was super naive that it wouldn't get, I didn't really even think about press. And the world's media just picked it up and were just like, this is the world's most advanced bionic arm, which it wasn't really. It had a prototype Open Bionics hand on it, and they make 3D printed bionic hands. And since that prototype, they've developed medically approved arms. And that's an incredible achievement because they're just really affordable arms. And I encourage everybody to look them up, because that's something that I think has stemmed from that project. Maybe even just the attention that project got has developed accessible technology for people.
That's really good. And cost effective, like you say, you know, that's what makes it accessible for
Absolutely,
people. Absolutely,
yeah.
So what do you hope to see invented next? Like if you could invent something, or someone's watching now, what technology do you still need in your life?
Yeah, I'm super excited, honestly, for the next control scheme that I'm got in the works. There's an ARM build going on currently that has 2 electrodes, so it's almost binary control, like control the grips, just open and close and switch it into different ones. This new technology called CoAPT, second generation, it's machine learning that understands a whole array of electrodes on your body to more accurately sort of uncover what your brain's intentions are. So it would give me direct control of a flexion and extension of an elbow and wrist rotation and possibly different grips. So that is an incredible advancement. And they've just won an award. And I just look at that technology and think this could be applied into so many areas of technology. Yeah. Other than that, I think attaching the prosthetics to the body is the main challenge that we all have, control and attachment. I would get so much more control if I had a titanium bone anchor. So something that bridges the device and the body. And the main challenge with that is infection, because there'll be metal sticking out of you.
Yeah. And one thing I had to ask, again, because my students are massive video gamers, as my family and my brothers, what video games do you play?
Right now, I'm just playing Miles Morales on PS5.
Oh, okay.
I fortunately got one like a couple of weeks ago.
I'm an Xbox person, so I'm not sure we can talk anymore.
Oh, sometimes.
Well, we've been completely sort of awestruck by your story, James. Thank you so much for coming in.
Thank you so much for joining us, James.
Thanks.
Thank you. Oh, I am totally awestruck. I mean, it's absolutely amazing, so inspirational. We have some fantastic Femtech stories from 2 amazing women who use their life experiences to develop solutions to help others have a better experience than themselves. And of course, it's day 3 of Andrew's Bakeneering. What are you building for us today?
Well, today, Bobby, I'm going to be explaining re-entry from the Earth's atmosphere through the medium of a retro dessert.
Fantastic. On top of all of that, we have Mark to help us bring engineering news from around the globe. Mark, where are you taking us today?
Well, Bobby, today we'll be travelling to the USA, China, Europe and the UK. More great global news stories to come, so stay tuned, Bobby.
But now, get your baking soda and vinegar at the ready. Callum is going to show us how to make an exploding rainbow.
Thanks, Bobby. Let's get started. So the ingredients we're going to need for this experiment are rainbow food colouring, baking soda, white vinegar, a small cup or container, and a spoon. So the first step to this experiment is put 1 to 2 drops of food colouring into each container. All right, there we go. The next step is we fill the containers or cups halfway with vinegar. All right, now we drop 1 to 2 teaspoons of baking soda. Oh. As you can see, it's fizzing. Now it's bubbling. Now it's rising. Did you know that carbon dioxide is a gas that's created when vinegar, which is an acid, and baking soda, which is a base, are mixed together?
Wow, that is lovely. It's a very pleasing way of showing how carbon dioxide can be produced, isn't it? And the reaction that it's caused by the simple mixing of an acid with a base.
Absolutely fantastic work, Callum. Loving how visual your experiments are. Well, as part of our 150th celebration, the IET awarded 16 world-leading engineers and technologists with an honorary fellowship for their outstanding contribution to the engineering and technology industry. One of those recognised is Professor Henrietta Heald at the Ben-Gurion University of the Negev in recognition of his research achievements in semiconductor technology.
And I was lucky enough to catch up with Professor Henrietta Heald earlier this year to talk about his research in the field of semiconductor technology.
Tell us a bit about your job and your career.
I started my career in the Israeli Air Force as a radio technician. Okay, this was in 1957. And I advanced until now, the 63 years of career. So where will I start? I leave it all away, but what I want to say that the most interesting part of my career is my research. And I've been doing a lot of research on diversified subjects. Something happened, okay, on diversified subjects. And this is the most interesting, and my subjects are mainly regarding semiconductor-based electronic and optoelectronics materials and devices. Okay, that's my subject. That's what I'm doing mainly. I also teaching the same subject. My teaching career is longer than my research career. I'm teaching for 62 or 63 years, but my research career is only 55 years since I started in the academy. My career can be summarized in this way. I always choose the difficult subjects for research. I don't go for the easy ones. I choose the subject that other researchers are reluctant to choose, either because it's too difficult or too long, or the probability of success is low. I look specifically for this subject. And I must say that in most cases, not in all cases, but in most cases, I was successful. I will never retire. I hope, and it's not a joke, I mean it, that when my last minute on earth will come, I will stand and teach. I want to finish my life teaching at that moment. What I hope is to produce more students that will occupy higher and higher levels. My past students are already themselves are professors, many of them. And many of them became managers and in a high position in the industry. So I hope to achieve more and more of those. This is in teaching. Today, the connection between transistors is with aluminum wires. Yeah. This causes delay in the transmission of signals. I want to take it out and to transmit these signals from transistors by light, mathematics. Study more mathematics, because as much as technology is advanced, mathematics come closer and closer to it. It's already converged into it. In modern technology, mathematics that they learn today is not enough. My advice to them is get books and study more than they teach you. Okay. Get higher and higher, otherwise you'll be behind.
Yeah. If you had to sum up engineering and technology in 3 words or phrases, how would you describe it?
Fantastic, in 1 word. Today, 1 vacuum tube equal to 1 transistor. Today, in 1 square centimeter, there are 1 million transistors. 1 million vacuum tubes in 1 centimeter square. Who could even dream about it? It's science fiction.
We'll be hearing from more of the 16 honorary fellows throughout the week. Still to come on today's show, we have 2 stories of how 2 women have used their own negative birth experiences to create a positive solution for others. We'll be speaking with Baymatob's CEO, Sarah MacDonald, about how her traumatic birth experience with her second child and how it made clear the need to do better in obstetrics monitoring.
Yes, and we'll also be speaking with CEO of Modi-Bodi, Kristy Chong, to find out how, after the birth of her second child, her experiences with bladder and period leaks made her determined to create Modi-Bodi, a better line of leak protection and the original leak-proof brand.
And don't forget the latest engineering and technology stories from around the world with the weather map of news. But before that, there's a delicious smell drifting through the studio.
Today, I'm looking at aerospace engineering, particularly what links safely returning astronauts from the atmosphere to a retro desert. It's all about managing heat in re-entry. Now, re-entry is one of the most intense things a human can experience. Forces of up to 5G. We're decelerating from about 18,000 miles per hour. NASA astronaut Doug Wheelock described it as like going over Niagara Falls in a barrel, but the barrel's on fire. That kind of gives you an impression of how vivid the experience is. And it generates an incredible amount of heat, both through compression of the air just in front of the spacecraft and through friction. It generates temperatures of up to 1800 degrees C. So how do we keep our astronauts safe? What are the strategies we can use? Well, there are 3 main things. The first one is the choice of shape of our spacecraft. So we can either go for long and slender, which you might think is intuitive, or something a bit more blunt. And what NASA researchers found out is if you go for something long and slender, what actually happens is it overheats, because as you compress the atmosphere as it comes back in, it overheats a very small area and it can melt or destroy your spacecraft. So what they actually found, which is not very intuitive for aircraft on Earth, is that you actually want to be as wide as possible. So if you're coming in with a very blunt surface, for twice the area, you get half the heat loading. So being bigger really is better. That's why the space shuttle launches vertically, comes back in on its belly. It's why the Apollo capsule comes in with a wide surface area. So that's the first thing we can do. Second thing is we can just decide to burn off some of the material on the outside. This is what we call an ablative heat shield and is what was used on the Apollo missions. So what's a good baking illustration for an ablative heat shield? Well, you can blowtorch a ginger nut. It's a bit crude, does the job. Let's go and have a look. So if I pop a ginger nut there, and hopefully you'll see when I torch it, it starts to give off a bit of a flame and releases some gas. Now, what you can see is the surface looks a little bit mottled as we've started to burn it off. And that actually acts as a cushion, or what we call a bow shock, in front of the spacecraft coming back in and helps keep the surface cool. So that's the second thing, ablative. What's the third thing you can do? Well, you have to insulate the rest. And we can actually use air as an insulator, because when air is in pockets, it's incredibly good at being an insulator, similar to your duvet or double glazing. I've actually got over here a tile from the Russian space shuttle. This was the Buran, and it's about 95% air by volume, and it's incredibly light. And I could blowtorch the top of this, and I could safely hold the bottom. I could blowtorch the entire top of this and just hold the bottom for 10, 15 minutes. It's just an incredibly good insulator, and it uses silica. But we can make an edible version of this as well to illustrate the same principle. And that's where a baked Alaska comes in, using meringue. So we're going to make a Swiss meringue to start with. And a Swiss meringue is just heated over a bain-marie until it gets to 72 degrees C. So I've cleaned out a bowl here with some lemon juice, and I've got 130 grams of granulated sugar. And I've also got 3 large egg whites that I'm going to pour in as well. And then I'm going to pop on my hob until it's simmering. I'm just going to whisk this over the heat with a digital thermometer until it gets to 72 degrees C. So I've got my egg whites and my granulated sugar in there, and I'm just going to pop it over some simmering water. I'm just going to whisk it continuously. Now the key with the Swiss meringue is you need to keep it moving, and I want to bring it up to 72 degrees C, so I'm going to use the digital thermometer to check. And that stabilizes the eggs and also ensures that it's safe to eat. Now the other bits of a baked Alaska are a sponge base, which I've prepared already. I've got a hazelnut and lemon sponge. And then I've got some ice cream, which I've cast into a dome, which is going to go on top. And the idea is that the meringue is going to insulate the ice cream from the intense heat of my blowtorch. Okay, so once that's hit 72, immediately take that off the hob, straight into the stand mixer, and pop it on a high speed for about 3 to 5 minutes until the bowl is cool to the touch and it's at nice stiff peaks. Cool, so the bowl's completely cool to the touch. My whisk stands in the middle, stiff peaks, and of course, the test for all time, stiff peaks. So meringue is ready, sit to one side. I've got my sponge over here, which is going to be my base. And then I've just taken my ice cream out of the freezer. So I just froze it in 3 different layers, 3 different flavors, just for a bit of interest. And I just need to get it out of the mold. So once you've got your dome of ice cream, and I just put some cling film on that, then you're going to carefully pop it on top of your sponge base. Make sure it's nice and aligned. And then pretty quickly, you're going to want to get your meringue on top. So get your meringue. I've got a small offset palette knife just to smooth this. And you can afford to dollop quite generously. Look at that. And that just goes on top. If you're going for a statement cake, you could just blowtorch that as is. But I'm going to put a whole layer on. So just dollop it nice and high before smoothing it down the sides. And when it's blowtorched, it's going to be amazing. The Buran tile that I was showing you is about 95% air by volume. Meringue is about 80%. So it's not quite as light, but it's not too far away. And meringue is a really good insulator. If you put a dollop of this in the freezer, when you taste it, it will taste warm. It won't taste cold. And that's the same reason why if you step out of bed in the morning and you step on the carpet, it feels warm. But if you step on a tiled floor, it feels cold. And that's what the meringue's doing to your tongue as well. If you try it straight from the freezer, you're tasting lots of little insulated pockets. So it doesn't taste as cold as, say, an ice cube would. So the center of that blowtorch is at about 1800 degrees. We're caramelizing the meringue instantly, but it's only the very, very outside layer of this. And I've actually blowtorched one of these to destruction for about 10 minutes. It starts to smell pretty bad, but it still protects the ice cream on the inside. But we've got to do the test. We've got to cut in and see if it's done its job. So we're going to go in for a slice, see if it's worked. Ooh. In the moment of truth. Ho, ho, ho. There it is. Slice of baked Alaska. And all the ice cream still rock hard in the middle. And interestingly, the meringue, it's only about 3 times worse an insulator than a space shuttle tile. So if you do happen to be in orbit, make sure you bring some spare egg whites with you, because the baked Alaska might just save your skin.
We've got to get him to bring some of that down here before the crew get it. Can we get it? Can we get some of that in here?
Fingers crossed.
Yes, I hope so. Now, Femtech, or female technology, is a booming sector which primarily addresses women's health, including fertility solutions, period tracking apps, pregnancy and breastfeeding care, women's sexual wellness, and reproductive systems healthcare. From prescription birth control apps and tampon alternatives to wearable fertility trackers and internet-connected breast pumps, women's health tech made massive strides in the past few years.
Why is Femtech so important? Well, Femtech represents a notable departure from a market which saw mostly male products and technologies going mainstream, while products aimed at addressing basic women's health issues remained largely invisible.
From Femtech companies through to scientists, VCs and users, we can see that we're finally moving away from the idea that women's health is niche and something to be only spoken in whispers. This is a fantastic driver for a more equal and healthy society, not only for women, but for everyone.
Joining us now is CEO of Modi-Bodi, Kristy Chong, a mum on a mission. I'd love you to tell us about Modi-Bodi and what the company does.
Sure. So Modi-Bodi is a line of, we like to call it sustainable health apparel, which provides a total replacement to disposable hygiene for the management of your periods, incontinence, sweat, and other bodily leaks.
Kristy, what was the moment that you thought, no, I'm going to have to do this. I'm going to have to set up a company and bring these ideas to market?
Yeah, I mean, it was one step at a time, but the idea for Modi-Bodi actually came about after the birth of my second child, and my periods had not long returned, and I got some leaky bladder, as 1 in 3 mums do, and I was in training for a marathon. So that's where the idea came about. And then I spoke to my husband about, the fact that women and people have been putting up with disposable hygiene as the only option, which is irritating, uncomfortable, and really bad for the environment. And I just thought that wasn't good enough. And I was living in Seattle, I was surrounded by tech, and I just thought it was time. It was time for, a better, more sustainable solution. And one little step at a time. That's how I say you go to building a business. You think big from the start, and then you take one step at a time.
Kristy, you are such a social advocate for women's health issues and rights as well. And I truly think the work you do in this area is absolutely amazing. But I keep thinking, what made you and what keeps you so passionate about this?
I wanted to champion limitless positive change, and that's what our brand is all about. So in everything we do, we think about how can we create better change and empower the people that we're serving in our customers. And so, we've always gone about trying to normalise the conversation around bodily leaks, periods and incontinence. We've used a diverse range of models to be very inclusive of, who we represent and who we're talking to. And we also have a huge part of our mission is to give back and put an end to period poverty. It is a significant amount of people in the world who don't have access to affordable, sustainable products to manage their periods. And this year alone, we're donating £1.1 million worth of product, which is over 100,000 pairs to people in need. But, we also partner with groups like Bloody Good Period and the like to champion those positive education around menstruation and bodies in schools as well.
Thank you so much, Kristy. Great work. Our next guest, again, is such an inspiration when it comes to really being passionate about the work she does. After experiencing a traumatic birth with her second child, our next guest, Dr. Sarah MacDonald, founded Baymatob. It's an Australian company specialising in the development of medical devices and believes it's important that the technology we develop is not only improving outcomes, but it's also working towards improving the experience of all users.
Sarah's company takes care to consider and work with the needs of patients, carers, clinicians, hospitals, and others who will need to interact with the technology. The company's mission is to develop minimally invasive medical technologies that work for all users to improve both outcomes and experience.
Sarah's vision is for a world where medical technology is used to detect problems, monitor interventions, and improve outcomes without negatively impacting on the individual's experience.
Well, hello and welcome, Sarah.
Hi, Sarah.
Thank you very much.
Well, Sarah, Baymatob sounds like a brilliant company. How do you explain what technologies your company creates?
Look, our primary focus at the moment's a device called Ollie, the namesake being my son, Ollie, my second child, which is a non-invasive method of monitoring pregnancy and labour progression.
Wow. And what was the pinch point for you that drove you to set up this company? You mentioned, obviously, your second child there. Was it sort of the sudden, I have to do this, or did it sort of grow through lots of other smaller pushes?
I would say it was that whole birth experience. So my first child was a completely normal birth experience, no interventions, and the process just it seemed to flow and be quite normal, and I fondly look back on. Ollie was quite invasive, so I went into preterm labour and was literally tied down with, I'm not sure everyone's seen this, but one of these, which is the current standard, more or less. And it made the experience a lot more traumatic, but even worse than that, I'm a mechatronic engineer by training, learning that the signals that technology is providing wasn't actually helping clinicians, it was more as a medico-legal checkbox. And everyone knew that that technology wasn't working, but they've got nothing else. So I had an idea as a mother going through that experience that specialises in sensors and signals, how to quantify that into a multimodal device.
You're talking about your products. Tell us about some of the products that you are really most proud of and the specific technology used there.
Yeah, so Ollie itself is a multimodal sensor. We use completely new measures to basically identify how the woman is progressing in labour and pick up complications much earlier than current methods. So I've got one of our devices we're using in the pilot studies at the moment. The device itself has multiple sensors throughout it and different types, is attached to the maternal abdomen. One of the big areas we're looking at present are things like detecting postpartum hemorrhage well before the hemorrhage and birth actually occurs. And being able to identify and alert clinicians in order to prepare for that event prior.
Sarah, did you talk to lots of other expecting mothers about this, and people who were experiencing the same problems as you?
Yeah, and we still do. Part of this whole process. So when I first came out after having Ollie, and I had this idea, I spoke to numerous people to try and get it off the ground, and I was effectively in a position where, because I wasn't a doctor, it wasn't listened to, even though we had doctors, mothers, everyone saying we need something. I ended up doing a PhD in medicine, and with that ended up being able to speak to a lot more people, both within the clinical environment, but also mothers going through experience, which really helped us be able to build and develop the product to best suit all users. Because at the end of the day, as a mother, the current gold standard not just fails me, but it also fails both clinicians, hospitals, and the health system as well.
Yeah. And how much of your engineering background has really helped you with this?
Tell you what, I think statistically it's unusual for a woman to have a normal experience, then have a complicated experience. And being a mechatronic engineer who is able to then compare what normal feels like, and then feel what abnormal feels like, and have a background in sensors and signals that you can quantify that difference. It was definitely I couldn't put it into words, but I could put it into sensors that could collect the different feelings. But I think it was quite important from that context. In addition to that, I think just the general problem solving side of it, and being able to come from it as a user as opposed to an engineer being told to monitor. So that's why we've got this, is engineers are told we need to pick up fetal heart rate, as opposed to immersed in the environment and realise that maybe there might be something else that we need to pick up instead of just monitoring fetal heart rate.
Brilliant. Oh, well, best of luck with it as well. And it's such an important thing. So we hope to see it in the UK at some point as well. Thank you so much for joining us, Sarah. It's been a pleasure to talk to you.
Thank you for having me.
Wow. 2 amazing stories there of how you can take brilliant ideas to market and literally make a huge difference.
Absolutely. And now with some brilliant stories from around the world, we've got Mark warming things up again with the weather map of news.
Thanks, Bobby. The forecast really is looking hot today with some great new technologies and engineering stories. So let's get that map going. We're starting over there in the USA, and it's the University of Vermont, where a computer scientist and robotics expert has developed tiny hybrid robots that could one day be used to swim around human bodies to specific areas requiring medicine, for instance, or to even gather microplastics from the oceans. These novel living machines are only 1 millimetre wide and are known as xenobots, living programmable organisms. Next, we're going to, it's the UK, And it's here in London, where entrepreneur Arthur Kay's big idea is to use his company, BioBean, to turn 85% of coffee waste into biofuels for heating buildings and powering transport. London's coffee industry creates over 200,000 tonnes. Yeah, that's correct, 200,000 tonnes of waste every year. So this would be a fantastic solution to turn that waste into something good and useful. Next, we're going over to China, where during the COVID-19 outbreak, the country saw a massive uptake in the use of unmanned remote technologies, like drones and robotics, to provide services to residents. China's Cloud Mines introduced its robotics into the hospital in Wuhan, thought to be the centre of the country's outbreak, to help staff on wards by delivering food and medicine to isolated patients. The robots are powered by people, controlling them remotely using 5G. This is China's first ever entirely robot-led ward and is an opportunity to test the capability of this type of technology. And in Germany, they are focusing their efforts on manufacturing SMEs. The SME Robotics project aims to develop a new kind of manufacturing robot that is simple and intuitive to use, without the need for complex programming, and which crucially is able to adapt to changes in manufacturing processes rather than being designed to simply carry out repetitive tasks. And finally, did you know that UK homes throw away 30 to 50% of what we buy from supermarkets? An invention called Bump Mark could change all of that. Originally developed for blind people, it's a smart food label that starts out smooth to the touch, but then gets bumpier as food decays. And since it decays at the same rate as any protein-based food within, it's far more accurate than printed dates. Well, that's it for today. I'll be back in episode 4 with more news from around the world. So back to Dan and Bobby in the studio.
Well, Bobby, what a show. Inclusive engineering is really important if we're going to head off the skill shortage and really bring equality into the world of engineering and technology. But I think we have shown that there is a lot to be very positive about in our 150th year.
Whoa, hang on. We've got some cake coming. Oh,
look at this.
Word.
It is the cake as well. Oh,
it's been a total pleasure. Great guests. Difference makers, all of them, and stunning cake. Another show, same time, same place tomorrow.
Absolutely. And episode 4 is set to be another cracker. Thank you to everyone who has tweeted and got in touch through our social media channels. And to all our viewers, have a safe rest of your day and see you at the same time tomorrow.